See here, now I will consider a charge. This is a point charge, also called isolated charge. ಒಂದು ಚಾರ್ಜ್ ಅನ್ನು ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ತೀನಿ and its magnitude is capital letter Q. Here capital Q is a charge. Okay, and around this charge, ಈ ಚಾರ್ಜ್ ಸುತ್ತಲೂ there is a particular region, there is a particular space. ಈ ಚಾರ್ಜ್ ಸುತ್ತಲೂ ಒಂದು ನಿರ್ದಿಷ್ಟವಾದ ಸ್ಪೇಸ್ ಇದೆ. ಏನಾಗ್ತದಲ್ಲಿ ಸಿ ಕನ್ಸಿಡರ್ ಎ ಚಾರ್ಜ್ ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ column and this charge is having some region. What happens in that region? See here, this is positive charge. Okay, if I place a small amount of charge, that small amount of charge is also called test charge. Test charge anta kariteve. Now I will consider a consideration point. I will consider one consideration point. It is P. I will consider one consideration point P. Okay, and I am going to place a small amount of charge, which is also called as test charge. If I place a test charge here, small amount of charge, say it is Q0, then what happens? It is also positive. Then what happens? Already you know the properties of electric charge. Like charges repel each other. Okay, see here, when I keep the small amount of charge, that is a test charge, at a point P, then what happens? This capital Q repels this small Q0. This point charge repels the test charge in this direction. Getting the idea? Getting the idea? Here, when you place the test charge at a point P, then this plus Q charge, this point charge repels the test charge in this direction. That means the Q0 charge, test charge, is experiencing the electrostatic repulsive force in this direction. Electrostatic repulsive force in this direction. Getting the idea? And is going to repel along this direction. Getting the idea? If you place the same Q0 charge, if you place the same Q0 charge here, Q0 charge, then also this plus capital Q repels this Q0 charge along this direction. Getting the idea? If you place Q0 charge here, then also this capital Q repels the Q0 charge in this direction. Getting the idea? If you place the Q0 charge here, then also this plus capital Q repels the Q0 charge in this direction with a force F. If you keep the Q0 charge here, then this plus capital Q always repels this Q0 charge in a particular direction. Getting the idea? But if you place the same Q0 charge here, then it will not experience the electrostatic repulsive force. Then this capital Q will not repel this. If you place here, then also Q0 will not experience the electrostatic repulsive force. If you place here, then also Q0 will not experience electrostatic repulsive force. If you place here, the Q0 will not experience the electrostatic repulsive force. This means what? Only in this particular region, the Q0 charge, test charge is going to experience the electrostatic repulsive force, and this region is called what? Electric field of this charge. Getting the idea? That means the space around the point charge, where small amount of charges, where other charged particles, where test charges experiences the electrostatic force, and that space around the charge is known as electric field. Getting the idea? ನೋಡಿ, ನಾನು ಮೊದಲೇನ್ ಮಾಡಿದೆ, ಒಂದು ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಅಂತಕ್ಕಂಥ ಚಾರ್ಜ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡೆ. ಯಾವ ರೀತಿ ಮ್ಯಾಗ್ನೆಟ್ ಸುತ್ತಲೂ ಸರ್ಟೆನ್ ರೀಸನ್ ಇರ್ತದೋ ಅದೇ ರೀತಿ ಈ ಚಾರ್ಜ್ ಸುತ್ತಲೂ ಸರ್ಟೆನ್ ರೀಸನ್ ಇರ್ತದ. ಆ ರೀಸನ್ ದಲ್ಲಿ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಅನ್ನ ಇಟ್ಟರೆ, ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಚಾರ್ಜ್ ಇಟ್ಟರೆ ಅವು ರಿಪೆಲ್ ಆಗ್ತಾವ. ಇಲ್ಲಿ ನೋಡ್ರಿ, plus q naught ಇದೆ ರಿಪೆಲ್ ಆಗಿದೆ. ಸಪೋಸ್ ಇದು minus q naught ಇದ್ರೆ this plus q attracts the minus q naught. That is, it experiences the electrostatic attractive force. Here it is plus. That's why it is repelling in this direction. Keep it in mind. Okay. In this way, there is a particular reason, there is a particular space around the charge where test charge experiences the electrostatic repulsive force or attractive force, which depends upon the nature of the charge, whether they are like or unlike. Getting that? In this way, what is the definition of electric field? The space around the charge, the space around the charge where the test charges, where the other charged particles, where small amount of charged particles experience the electrostatic force. That space is called what? Electric field. Getting the idea? Getting the idea? See here, what is the definition of electric field? The space around the charge where other charged particles, that is test charges, experience the electrostatic force. That space around the charge is known as electric field of that charge. Getting the idea? Getting the idea? ಇಲ್ಲಿ ನೋಡಿ, ಈ ಚಾರ್ಜ್ ಈ ರೀಸನ್ ದಲ್ಲಿ ನೀವು ಕ್ಯೂ ನಾಟ್ ಅನ್ನು ಇಟ್ಟರೆ, ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಇಲ್ಲೆಲ್ಲ ಇಟ್ಟರೆ ಇದು ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಅನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತದೆ. ಅದೇ ನೀವು ಈ ರೀಸನ್ ಬಿಟ್ಟು ಇಲ್ಲಿ 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 ಕ್ಯೂ ನಾಟ್ ಚಾರ್ಜ್ ಇಡ್ರಿ, ಅಲ್ಲಿ ಯಾವುದೇ ರೀತಿಯ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಉಂಟಾಗೋದಿಲ್ಲ. ಹಂಗಾರೆ ಈ ಸ್ಪೇಸ್ ಗೆ ನಾವು ಏನಾಕ್ ಬರಂಗಿಲ್ಲ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನಾಕ್ ಬರೋದಿಲ್ಲ. ಹಂಗಾರೆ ಈ ಸ್ಪೇಸ್ ಗೆ ನಾವೇನ್ ಅನ್ಬೋದು, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಕರಿಬಹುದು. ಗೆಟಿಂಗ್ ದಿ ಐಡಿಯಾ? ನೋಡಿ, ನಾನು ಯಾಕೆ ಕಾನ್ಸೆಪ್ಟ್ ಗೆ ಹೆಚ್ಚು ಒತ್ತು ಕೊಡ್ತಾ ಇದ್ದೇನೆ ಅಂದ್ರೆ, ಇಫ್ ಯು ಡೋಂಟ್ ನೋ ದ ಮೀನಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ, then you can't understand the derivations, you can't understand the concepts, and you are not able to solve the problem. That's why I'm giving great stress to the concepts, to the definitions. Try to understand. Okay? Now, see here one more point is there. This point charge is also called as a source charge. Source charge ಅಂತ ಕರಿತೀವಿ. ಯಾಕೆ ಅಂತಂದ್ರೆ, it is a source for the electric field. ಅಂದ್ರೆ the charge which produces electric field around it, the charge which produces electric field around it, that charge is called what? Source charge. Here capital Q, it is a source charge. Why it is so called? Because capital Q is producing electric field around it. That's why this capital Q is called what? Source charge. Now, what is the definition of test charge? Test charge means simply small amount of charge compared to capital Q. And what is the scientific definition of Q naught? See here. Here test charge is nothing but it is the charge, it is the small amount of charge which experiences the effect of source charge. See here. ಇದರ ಪ್ರಭಾವದಿಂದ ಇದು ದೂರ ತಳ್ಳಲ್ಪಡ್ತಾ ಇದೆ. ಇದು ಪ್ಲಸ್ ಇದ್ರೆ, ಇದೊಂದೇ ಮೈನಸ್ ಇದ್ರೆ ಇದರ ಪ್ರಭಾವದಿಂದ ಇದು ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತದ. ಅಂದ್ರೆ the Q naught is experiencing the effect of capital Q. That's why Q naught is called what? Test charge. That is, test charge is nothing but it is the small amount of charge which experiences the effect of source charge. Now, you should understand what is the meaning of source charge, what is the meaning of test charge. What is source charge? The charge which produces electric field around it, that is called as source charge. Here capital Q is a source charge. What is test charge? The charge which experiences the effect of source charge, that charge is called what? Test charge. Here Q naught is a test charge. Getting the idea? Now, in this way, you came to know that whenever a small amount of charges, that is test charges, whenever a charged particles are kept in the electric field of source charge, and those small amount of charges, that is test charges, are going to experience the electrostatic force. Keep it in mind. Now, come to the next point, that is electric intensity. How do you know, dear students, what is the meaning of electric field? Now, let us study what is the meaning of electric intensity. What is the meaning of electric intensity? See here. Here, again I will consider a source charge, that is capital Q. Since it is a source charge, it is going to produce what? Electric field around it. It is going to produce electric field around it. Getting the idea? Getting the idea? See here, now I will consider a point P here. Now the point P is present where? In the electric field of source charge. Point P is present in the electric field of source charge. Now what I am going to do here? Here I will place a test charge Q0 at point P. What I have done? Here I have placed the test charge Q0 at point P, which is lying in the electric field of source charge. Then what happens? It is also plus, it is also plus. Then this source charge repels this test charge in this direction. Okay. Now this test charge is moving in this direction. Why it is moving? Because it is experiencing the electrostatic force. And this electrostatic repulsive force experienced by the charge Q0 when kept at point P is called as electric intensity at point P. Getting the idea? Getting the idea? Now I will consider one more point. Say it is A. A is a consideration point. When a small test charge is placed at a point A, then what happens? Then also it is going to repel. That is, it experiences the electrostatic repulsive force in this direction. And this electrostatic repulsive force experienced by the charge Q0 when kept at point A is called as electric intensity at point A. Now I will consider one more point. Say it is B. B is a consideration point. Okay. If I place a small Q0 charge, if I place a test charge at point P, then also it experiences the electrostatic repulsive force. Say F. This electrostatic repulsive force experienced by the charge Q0 when kept at point B is called as electric intensity at point B. Getting the idea what I am going to say? So yeah, electric intensity means what? Electric intensity at point P is defined as the amount of electrostatic force experienced by the test charge when kept at that point. What is electric intensity at point A? Electric intensity at point A is defined as the amount of electrostatic force experienced by the test charge when kept at that point A. What is electric intensity at point B? Electric intensity at point B is defined as the amount of electrostatic force experienced by the charge Q0 when kept at that point B. In this way, electric intensity at a point, electric intensity at a point is defined as the amount of electrostatic force experienced by the charge Q0 when kept at that point. This is the definition of electric intensity. Getting the idea? Now see here, what is the SI unit of electric intensity? See here, force, the SI unit of force is Newton and the SI unit of charge is Coulomb, then Newton per Coulomb. Newton per Coulomb, it is the SI unit of electric intensity. In this way, electric field and electric intensity are very helpful in solving the problems, in understanding the concepts in electrostatics as well as current electricity. Okay, my dear students, what is the meaning of electric field? Electric field means the space around the charge where other charged particles, test charges, small amount of charges experiences the electrostatic force. That space is called what? Electric field. What is electric intensity? Electric intensity at a point is defined as the amount of electrostatic force experienced by the test charge when placed at that point. This is the meaning of electric intensity. What is the SI unit of electric intensity? SI unit of electric intensity is Newton per Coulomb, because E is equal to F by Q0. F is an electrostatic force, Q0 is a test charge. SI unit of force is Newton and SI unit of charge is Coulomb. That's why the SI unit of electric intensity is Newton per Coulomb. Getting the idea? Getting the idea? And also, see here, if it is a, I will say one more important point. This is test charge, I mean point charge or isolated charge or source charge. It is a positive charge. See here, the direction of electric intensity is always away from the positive charge. And see here, here it is negative source charge. And the direction of electric intensity is always towards the negative charge. Keep in mind. Why it is so? See here. Here, positive charge is there. Here I have placed plus Q naught. Then the plus capital Q is repelling the Q naught in this direction. That is, the direction of electric intensity is in this direction. It is positive. If it is a negative charge, then what happens? It attracts the Q naught. That is, force is acting in this direction. That's why electric intensity is in this direction. That is, in case of positive charge, direction of electric intensity is away from the positive charge. In case of negative charge, direction of electric intensity is towards the negative charge. Keep it in mind. This is very helpful in derivations. When you are going to derive, this concept is very important. Please note down. Okay? Okay friends, today we are going to derive the expression for electric intensity at a point due to point charge. Already I told you what is the definition of electric intensity. That is, electric intensity at a point is defined as it is the amount of electrostatic force experienced by the charged particle when placed at that point. Now see here, what we are going to derive here. Here you are going to derive the expression for electric intensity at a point due to point charge. That means I have to consider a point charge here. See here, I will consider a point charge here. This is called what? This is a point charge. What is the magnitude of this point charge? Say capital Q coulomb. And I will place this capital Q coulomb at the point O. O is a consideration point. At this point, I will consider a charge of Q coulomb, capital Q coulomb. Now, since it is a point charge, you know that point charge is also called as source charge, because since it is a source charge, it is producing what? Electric field around it. It is producing electric field around it, like this. Okay. See here, now I will consider a consideration point, that is point P. Point P is a consideration point. Where I have considered this point, I have considered this point P in the electric field of capital Q charge, point charge. And what is the distance of this point P? I will consider the distance of point P from the capital Q is R. Okay. What is the distance of the point P from the point charge? That is capital R. See here, now I have to derive the expression for what is the electric intensity at this point P due to charge, due to point charge capital Q. That we are going to derive. My dear friends, here one more thing I will consider. What? Here at this point P, I will consider a small test charge, that is Q naught coulomb. What I have done? At the consideration point P, I have kept a small test charge Q naught. Okay. Now what happens, since the Q naught test charge is placed at a point P, which is lying in the electric field of the point charge capital Q, then what happens? This capital Q repels this Q naught charge. Why it is repelling? Because this is plus and this is also plus. That's why this capital Q repels this Q naught with a force F. F is a electrostatic force experienced by the charge Q naught, which is placed at point P. And this electrostatic force experienced by the charge Q naught kept at point P is called as electric intensity at point P. That we are going to derive the expression. Getting the idea? Nodi, ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿದೀವಿ? ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡೇವಿ. ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇದೆ, ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಕೂಲಂಬ್ ಇದೆ. ಇದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಆಗಿದ್ರಿಂದ ಇದು ಸುತ್ತ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಉಂಟಾಗ್ತದ. ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ದಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಪಿ ನ ಗುರುತಿಸ್ಕೊಳ್ತೇನೆ. ಆ ಪಾಯಿಂಟ್ ಪಿ ಈ ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಇಂದ ಆರ್ ಡಿಸ್ಟೆನ್ಸ್ ದೂರದೊಳಗಿದೆ. ಈಗ ನಾನು ಏನ್ ಮಾಡ್ತೇನೆ, ಕ್ಯೂ ನಾಟ್ ಅಂತಕ್ಕಂಥ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅನ್ನ, ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅನ್ನ ಪಾಯಿಂಟ್ ಪಿ ಮೇಲೆ ಇಡ್ತೇನೆ. ಆಗ ಈ ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಈ ಕ್ಯೂ ನಾಟ್ ಅನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತದ. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಬಲದಿಂದ ಈ ಕ್ಯೂ ನಾಟ್ ಅನ್ನ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿ ಇಟ್ಟಿರ್ತಕ್ಕಂಥ ಕ್ಯೂ ನಾಟ್ ಅನ್ನ ಈ ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಎಷ್ಟು ಬಲದಿಂದ ದೂಡ್ತದ ಅನ್ನೋದಕ್ಕೆ ನಾವೇನ್ ಕರಿತೀವಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಟ್ ಪಾಯಿಂಟ್ ಪಿ. Okay, let us derive the expression. See here, already you know from this figure, here two charges are there. First one is, that is Q1. Q1 is how much? Capital Q coulomb. And Q2 is how much? That is Q naught coulomb. Okay, two charges are there. And they are separated by distance R. They are separated by a distance R. Since Q1 and Q2, capital Q and Q naught are separated by a distance R, what is the electrostatic force acting between them? By what force this capital Q is repelling the Q naught? This can be calculated by using Coulomb's inverse square law, that is F is equal to Coulomb constant into Q1 into Q2 divided by R square, called as equation 1. Here Q1 is what? Q1 is capital Q, and Q2 is what? Q2 is Q naught coulomb, and distance between Q1 and Q2 is R. Therefore, equation 1 becomes what? Therefore, equation 1 becomes F is equal to K into Q1 is capital Q, Q2 is Q naught divided by R square. Okay, that is, here it is R, this is R square. Okay, called as equation 2. Now, see here, I will take this test charge Q naught on the LHS. Hence, what it becomes? F is equal to Q naught, that is equal to K into capital Q divided by R square. Getting it, called as equation 3. By definition, we know that the electrostatic force experienced by the charge Q naught is nothing but electric intensity at point P, that is equal to K into capital Q divided by R square. Okay, this is the electric intensity at point P due to a point charge capital Q. And also we can write this equation as electric intensity at point P is equal to, the value of K is 1 divided by 4 pi epsilon naught into capital Q divided by R square. Okay, this is the electric intensity at point P due to a point charge capital Q, called as equation 4. And we know that this Q naught is positive, this capital Q is also positive. That's why this capital Q repels the Q naught in this direction. That's why the direction of electric intensity is also along OP produced. Acts along OP produced. Getting the idea? This is the expression for electric intensity at a point due to a point charge. Note down. Okay, my dear students, now I am going to derive the expression for electric intensity at a point due to multiple charges. See here I will consider 3 charges, 3 or n number of charges. That is, say this is first one, second one, third one, and this is nth charge. Okay, and this is the consideration point. See here what I have considered. I have considered n number of charges. That is, this is Q1, this is Q2, this is Q3, and this is nth charge of the, this is the nth charge. Okay, I have considered n number of charges, and this is the consideration point, that is P. And what is the distance between charges and consideration point P? See here, these are the distances. Okay, here I will consider R1 is the distance of the point P from Q1, R2 is the distance of the point P from Q2, similarly R3 and Rn. These are the distance of the point P from the respective charges. My dear students, here already you know I have considered n number of charges of charge Q1, Q2, Q3 up to Qn. Let P be a point at a distance R1, R2, R3 up to Rn respectively. Getting the idea? Now we are going to derive what is the electric intensity at a point P due to Q1 charge, Q2 charge, Q3 charge and Qn charge. What is the total electric intensity at a point P due to all these charges, that we are going to derive. See here, my students, electric intensity at a point P due to Q1 charge is what? Electric intensity at a point P due to Q1 charge, that is electric intensity at P due to Q1 is E1 is equal to K into Q1 divided by R1 square, called as equation 1. Similarly, electric intensity at point P due to Q2 charge, E2 is equal to K into Q2 divided by R2 square, called as equation 2. And E3 is equal to K into Q3 divided by R3 square, called as equation 3. Therefore, electric intensity at a point P due to nth charge, En is equal to K into Qn divided by Rn square into Rn square, called as equation 4. Therefore, net electric intensity at point P. Therefore, net electric intensity at P due to n number of charges, is I will write here electric intensity at a point P due to n number of charges, that is E1 plus E2 plus E3 plus En, that is vector sum of intensity due to all other charges, that is EP is equal to K is taken outside and then Q1 by R1 square plus Q2 by R2 square plus Q3 by R3 square plus Qn by Rn square. This is the expression for electric intensity at a point P due to multiple charges. In general, we can write in general electric intensity at a point P due to n number of charges is 1 divided by k value is 1 divided by 4 pi epsilon naught into summation of qi divided by ri square, where r is integer. This is equation 4, this is equation 5, this is equation 6. This is the expression for electric intensity at a point P due to multiple charges. Okay, my dear students, now I am going to teach you what is the meaning of electric dipole and electric dipole moment. See here, now let us study what is the meaning of electric dipole. My dear students, here I will consider two metallic conductors. Say it is A and this is B conductor. Here what I have done, here I have considered two metallic conductor. First one is A, second one is B. Now let this A conductor is positively charged. This A conductor is positively charged. Getting the idea? And this B conductor is negatively charged. Okay? Getting the idea? This B conductor is negatively charged. Now what happens? In between conductor A and conductor B, there is a strong electric field. Now what I am going to do, between these two conductors A and B, that means in this region strong electric field is there. In this region I am going to place some medium. We know that this medium is containing either atoms or molecules. See here, whatever the medium I have placed between A and B, it is containing number of molecules, and these are the molecules of the medium placed between A and B. These are what? These are the molecules of the medium which is placed between A and B. Okay. Now, when the molecules of the medium are placed between A and B, that means what happens here? All molecules are containing equal amount of positive charges and negative charges. Since they are containing charges, what happens here? Here, what happens? Whatever the positive charges present in the molecules get attracted towards the conductor B, because unlike charges attract each other. Okay, see here, these are, that is positive, 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 and this is positive, 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 positive. Why positive charges are aligning, moving, turning in this direction? Because here it is negatively charged. Negative charges always attract positive charges. Already you know this. And whatever the negative charges present in the molecules get aligned towards the conductor A. That's all. Here negative charges are aligned towards the conductor A because it is positively charged. In this way, when a medium is placed in an electric field, the molecules present in that medium are containing equal number of positive and negative charges. When those molecules are placed in the electric field, the charges present in them are slightly displaced, and these displaced unlike charges which are equal in magnitude, these are known as electric dipoles. These are known as electric dipoles. Electric dipoles. In this way, electric dipole mainly consists of one negative charge and one positive charge, that is plus. Here negative charge means what? Electron. Positive charge means what? Proton. And I will consider the magnitude of electron and proton is Q and Q. What is the magnitude of this Q? The magnitude of this Q is what? 1.6 into 10 raised to minus 19 coulomb. This is the magnitude of charge on electron and proton. But the only thing is the charge on electron is negative and the charge on proton is positive. This is the only difference. In this way, here in these molecules, two equal, that is 1.6 into 10 raised to minus 19 coulomb, two equal and opposite charges, that is one is negative and one is positive, and they are placed at a certain distance, and this constitutes an electric dipole. At what time it is happening? When the molecules are placed in the electric field. The molecules like HCl, carbon monoxide, CO2, ammonia, when these molecules are placed in the electric field, the charges present in them get displaced like this, and these equal and opposite point charges separated by some distance constitute an electric dipole. Getting the idea? Now tell me, what is the definition of electric dipole? A pair of equal and opposite point charges separated by some distance constitute an electric dipole. And one more thing, that is the distance between these two unlike charges present in the electric dipole is called what? This distance is called what? Dipole length. The distance between the charges present in the electric dipole is called as dipole length. And I will take this dipole length as 2a. See here, because the midpoint O gives the position of the electric dipole. How it becomes 2a? This half distance is considered as a, and this half distance is considered as a, and a plus a becomes 2a. This is dipole length. What is an electric dipole? A pair of equal and opposite point charges separated by some distance constitute an electric dipole, and the distance between these two unlike charges is called as dipole length. For convenience, we will take the dipole length as 2a because midpoint O gives the position of the electric dipole. If P is a consideration point, I will consider a point P. If you want to measure the distance of point P from the dipole, from which charge you are going to measure? Either it is positive or negative. Tell me. Okay, neither positive or negative. It is always measured from the center of the dipole. Wherever the point, here, that consideration point is measured from the center of the dipole. That's why the O point, which is the center of the dipole, it gives the position of the dipole. Okay, this is about electric dipole. Okay friends, now let us study what is the strength of electric dipole. Already you know that electric dipole mainly consists of one negative charge and one positive charge, that is plus. Okay, this is the electric dipole. Okay, now see here, this is negative charge and this is positive charge. This is minus Q, this is plus Q, and this is called dipole length. Okay, with center O, and dipole length is 2a. Getting the idea? Now, to measure the strength of electric dipole, we are using a physical quantity which is called as electric dipole moment. That is, dipole moment is a physical quantity which measures the strength of the electric dipole. Now let us study how the strength of the electric dipole is calculated. If you multiply the magnitude of either charge, that is plus or minus Q, that is plus or minus Q into dipole length, then it gives the electric dipole moment of the dipole. Getting the idea? That is, electric dipole moment is denoted by capital letter P. In this way, electric dipole moment is defined as the product of magnitude of either charge and dipole length of the electric dipole. In this way, the strength of the electric dipole is calculated. Now, tell me what is the definition of dipole moment? Dipole moment is defined as it is the physical quantity which measures the strength of electric dipole. How the strength of electric dipole is measured? That is the product of magnitude of either charge and dipole length of the electric dipole. If you multiply this Q and 2A, that gives strength of the electric dipole, which is nothing but dipole moment. In this way, dipole moment of electric dipole is also defined as the product of magnitude of either charge and its dipole length. Okay, my dear students, here one more thing you should remember. This dipole moment is always having particular direction. The direction of this dipole moment is assumed to be from negative to positive charge, that is in this direction. That's why it is a vector quantity. Now tell me, what is the direction of dipole moment? The direction of dipole moment is always taken as from negative to positive charge. That's why dipole moment is a vector quantity. This is the magnitude of the dipole moment. I will write this equation in vector form. That is, vector P is equal to Q into 2A into small r p cap. Here small r p cap is the unit vector in the direction of negative charge to positive charge. And also the SI unit of electric dipole moment is coulomb meter, because the SI unit of charge is coulomb and the SI unit of dipole length is meter. That's why SI unit of dipole moment is coulomb meter. And this represents magnitude form of the electric dipole moment, and this equation represents vector form of the electric dipole moment.